Okay, in this podcast we're going to learn about redox, which are oxidation and reduction reactions. Oxidation and reduction happen in the same reaction, so they're affectionately called redox reactions. Okay. Whoops, there's a repeat. Alright, so first just a little bit about oxygen, because oxygen is used to be at least central to redox reactions. Now you can have redox reactions without oxygen involved. But oxygen is a really important element. It's the most abundant element on Earth. It's 21% of our atmosphere. It's 89% of the Earth's water as a compound. It's almost half of the Earth's crust as a compound. And it's 2/3 of what's in our body. So really an important material, also part of our food, and of course nasty stuff like rust. Some chemical properties of oxygen is it combines with lots of different things. So we are familiar with rust. If iron oxidizes, we form iron oxide, which is rust. It's that orange stuff. We form other oxides, other metals. Only iron rusts, but other metals will oxidize, which means that they react with the oxygen and form a metal oxide. Like aluminum oxide would be a film over the aluminum. It makes it look dull. And of course, oxygen is also part of hydrocarbons and requires things like hydrocarbons or things that burn require oxygen in order to burn. So, for instance, the Bunsen burner in our lab uses methane gas, but it would not burn unless there were oxygen in the room that allows it to happen. So oxygen is critical as an element. So there's two ways of looking at oxidation and reduction reactions. The first is how it used to be defined, which was oxidation involves something gaining oxygen atoms, and reduction involves something losing oxygen atoms. Today, however, the definition is broader in that oxidation is now considered to be the loss of electrons, and reduction is a gain of electrons. And the bottom line is that now oxidation can apply to reactions where there is no oxygen involved. So what we are going to focus on is this definition, because this is the one that applies today. Okay. So oxidation involves gaining oxygen and losing electrons. The reduction step involves losing electrons and gaining electrons. These always happen in pairs. So if one element in the reaction is being oxidized, the other is being reduced, because one atom is going to lose oxygens and the other atom is going to gain it. One atom loses electrons and the other atom gains those electrons. So it's important to remember that oxidation and reduction reactions always occur together. You can't have one without having the other, which is why we call them redox. They're both reduction and oxidation together. And you can't have them without each other. And that's because we end up with a conservation of electrons, where we're balancing electrons. Electrons lost equal electron gained. So loss and gain occur at the same time, so oxidation and reduction occur at the same time. So electrons are really the workhorses of chemical reactions. It's the electrons moving and creating bonds that cause compounds to be made, bonds to be broken. So protons and neutrons are just there along for the ride. The electrons are what does all the work. And this is what happens in oxidation reactions. So in order to talk about oxidation and reduction reactions, we have to talk about oxidation numbers. And oxidation numbers you can kind of think about as kind of like the charge assigned to an atom when it's part of a compound. So there's some basic rules, and I'll just go through those, and then we're going to do some practice. So the oxidation rules say the oxidation number for an atom in its element is always 0. And we know that, right? We know that any element, when it's by itself, is neutral. And so this applies. It's just the same thing. So in this case, it's just like the charge. Oxidation number, whether it's a diatomic element or a non-diatomic element, its oxidation number will be 0, and that's its charge. The sum of the oxidation numbers for all atoms or ions in a neutral compound is also 0, just like the charge on any compound is 0. Okay. The oxidation number of an ion is the charge of the ion. So again, oxidation number and charge mean the same thing. So if I have the sulfide ion, it's a -2. That's its oxidation number also. Same thing for aluminum. It's a +3. So its oxidation number is +3. The carbonate, here's a polyatomic that has a charge of -2. The oxidation number for that same group is also -2. So it's really just like a charge. Couple little things is hydrogen has 2 possible oxidation numbers. We actually talked about this when we did reactions. It can be a +1 when it's combined with a nonmetal. Let's say when it's in hydrochloric acid, it's a +1. Or it can have a -1 if it's bonded to a metal. So if I NaH, it's going to be a -1, right? Here it would be a +1. So that's really it. So let's identify the oxidation number of each element. Okay, so iodide is an element, so its oxidation number is going to be 0. Now, oxidation number of oxygen here is always a -2, right? So this is a -6, so the oxidation number on chromium must be a +3. Oxidation number on a chlorine is a -1, so and aluminum is +3. Now here's where it gets a little bit tricky. So the oxidation number on a sodium is a +1. It's a total of +2. Oxidation number on oxygen is -2. That's a total of -8. And it's usually this middle guy on a ternary or more, a compound that has more than 2 elements, that we're trying to figure out. So right now I've got a -8 and a +2, which is a -6. In order for this whole thing to be 0, this has to be a +6. So the sulfur is a +6. Alright, we said hydrogen, when they're bonded with the metal, are going to be -1, and the calcium would be +2. Okay. So when we're looking at reactions, we've got to be able to decide whether an element's being oxidized or reduced. And there's a couple different ways to do this. The way I like the best is when you look at what happens when an element goes from the left to the right of the equation. If its charge gets reduced, it's reduced. If the charge goes down, right? Some people like using the mnemonic that says Leo, the lion says grr, and what applies here is loss of electrons is oxidation, and gain of electrons is reduction. Okay, but let's take a look in practice. Alright, so here I have an equation. Let's just go ahead and identify the oxidation number of everything involved. The oxidation number of aluminum is 0, because it's an element. The oxidation number of iron would also be 0, because it's an element. The oxidation number of oxygen is a -2, so the iron is going to be +3. The oxidation number of aluminum is a +3. The oxidation number of oxygen is a -2. Okay. So because aluminum increased from 0 to +3 and iron decreases from +3 to 0, I like doing the decreased one. If this charge on iron reduces, that means this one, it is reduced. Okay? And the opposite way, aluminum going up, means it's oxidized. Okay? So you could do Leo the lion says grr, right? But I like doing if the charge goes down, it is reduced. Let's take a look at a couple here. Zinc goes from here as a metal, it's going to, as an element, it's going to be 0, and it's going to go up to a +2. So it's not reduced, so it's going to be oxidized. Iron goes from +3 to +2. That charge goes down, or it's reduced, so it's reduction. Alright, so let's take a look at each of these. Calcium, the oxygen is a -2. Calcium's a +2. My total negative charge here is -6. Calcium makes it a +2. So right now I'm at a -6. I'm sorry, a -6 plus 2 gives me a -4. So this must be a +4 in order for the whole compound to be 0. Calcium is a +2, oxygen a -2. Here each oxygen is -2, so the carbon must be +4. So let's take a look and see what we can identify in terms of what's been reduced or oxidized. Calcium does not change, so it's not involved in the redox. Carbon goes from +4 to +4, no change there. And oxygen goes from -2 to -2. So this is not a redox reaction. There's no change in charges as we go from left to right in the reaction. Let's look at silver nitrate. Here silver is 0. So here silver is going to be a +1 because it's an ion. Oxygen's a -2 for a total of -6, negative, +1. So my nitrogen must be +5. Now my silver goes from +1 to 0. So the silver is going to be reduced. And that's going to do it for now.